anyone that was at PhoneGap Day in US at Salt Lake City, we had a bit of a Twitter poll because we basically had a flow off. So Alex, who is our next presenter, with his long flowing blonde locks, was put up against Bruce Lefebvre, who's sitting over there who had this wonderful brunette flow going on. Sadly, since that, well, not sadly, it's a happy occurrence because since that time, Bruce and his lovely wife Diane have had a kid, but you know what happens when you have a kid? They like to grab at your hair. So that's what happened to me, really, seriously. So, yeah, 13 years ago. So that's why Bruce has shorter hair. But now, Alex feels like he was wrong. He feels like there was some gerrymandering going on back in Salt Lake City. So we have a Twitter poll up on PhoneGap. So go to the PhoneGap Twitter account and vote. Do you think that Alex has the best flow or Bruce has the best flow? Because we need a recount here.
This matters, by the way.
No, this is for serious. This is the most important thing that you do today, okay? All right.
Is
Thanks,
there
everyone.
a third option for your hair?
No. No. All right. Thanks, guys.
Hello, everybody. I don't know if this is going to cause double mic problems, so I'll just quickly stand over here. You can talk. It's fine. Can I do that? Is technology going to work? It's a real big treat to be here. Huge fan of the PhoneGap team. I've been with this thing in some form or another since the very beginning. In our earliest moments, our goal was to cease to exist, so we totally fucked that up. 9 years later, I just checked the stats. PhoneGap was downloaded in the last year 5 million times. When I left Adobe in 2015, it was downloaded 2 million times. So it's actually doubled its growth since I left, which means that you guys are doing way better now that I'm gone. One of the most important parts of a great native app is the animations and how it looks. Users will know if you don't do a good job here, and Alex has been working on this for a long time. So I want to invite him up to the stage. Give a hand for Alex.
Thank you. Can everybody hear me okay? Awesome. So as Brian said, I'm here to talk about animations for web and hybrid. The reason I put web there is it's basically the same thing. Most of the examples I'll show you today are actually going to be happening in a desktop browser, which is the same, just because it's a bit easier to run the profiler and it's bigger to see in the examples. So before we get started, just a quick spiel. I actually run a company called Isle of Code based in Toronto and Houston, of all places. We do a lot of JavaScript framework consulting, mostly with Ember, build a lot of hybrid apps. I won't say much more than that, but if as I'm speaking you're like, holy shit, I want to throw money at this guy, there's a mechanism to do that. It's what it's for. Other important thing to note, which is what really led to animations, is we actually built originally a project called Ember Cordova. It started as a series of bash scripts that became its own CLI inside of Ember to kind of package Cordova apps inside of Ember, unify those pipelines, give you live reload and a whole bunch of extra features. So if you're an Ember user, check that out. But a couple of weeks ago, we actually released something called Corber, which is basically Ember Cordova that also works for Vue, also works for Glimmer, also works for React. It's nothing like an Ionic at all. So if you're using Ionic, it's a completely different thing. They're not even really against each other. This is just giving you a bit of a dev flow if you're using something like a Vue and you want to add live reload and icons and some basic stuff. No UI library, nothing like that is included. I'm not going to do a demo. So what we're going to talk about today is a couple of things. The first thing is just, what are we looking for when we're building a good animation? How do we define that? How do we profile that? I'm going to show you some examples as well. Basically, I've gone and built the most naive one at the start, which is how I see people build this when they're first going. Then we just look at what's wrong with it, and we'll slowly make it better as we go. Then if we get some time, I'm just going to talk through some of the other options that we have that are maybe not fully supported in every browser yet, but are coming out more. Like your JS animation API, for example, promoting layers if that's something you want to do, etc. So jumping into what makes a good animation, first thing we want to think about is our FPS target. If you've never thought this way before, we generally want to be hitting about 60 frames per second, and I will show you how to measure this as well if you've never done it. Why is it 60 frames per second? 1,000 milliseconds, 60 frames per second. 16.6 is how much time we have for each frame. 60 FPS is where we basically believe that a user can't really see that chunking going on, right? It's pretty smooth. The worst thing you can do, though, is to not have a consistent frame rate. So sometimes what will happen, especially as you're working in JavaScript, right, is that thread's going to be getting clogged all the time. and you can't actually achieve a constant 60. So in that case, as you're profiling your app, it's actually a bit better to go for a constant 30 or a constant 45 or something like that than going to 60, down to 30, back up to 45. And you'll actually see that in the examples, right? You'll see something that looks pretty smooth at stages, but you can watch it like lurch to a halt at different times, and that you're basically observing a frame rate drop there. And in terms of our choices of how we do these animations, there are really two different things, our decorative and imperative. So decorative are what we'd call our CSS animations. Generally speaking, they're the most performant, but honestly, they can be pretty gnarly when you're doing complex stuff. Again, you'll see examples of these as we're going through. The reason these are faster, right, is the browser basically knows everything we're going to be doing up front. So there's some optimization that's happening on your behalf. And also, just because they're a bit harder to write, you can't write some of these complex cases that you'd see people doing in JavaScript, for example. So our other choice is imperative, which honestly, when we go and look at people's apps, is mostly what they've ended up doing. So the type of thing you'd see in imperative is a bounce or a bounce scroll, putting a bunch of things across the screen where we don't know the starting position ahead of time. These will run on the main thread. If you write your CSS animations correctly, they won't. So kind of easier to write, not as performant. What we're going to look at as we're writing JS animations is we'll look at request animation frame as well, which is a way to maybe give those a bit of a kick up. Before I get into the examples, though, I want to quickly cover as well, how do we profile and see what's going on with these animations? Because honestly, I've walked into so many places when you ask them, like, how are you measuring whether this is working? And they legitimately just eyeball it and like, yeah, it looked good. That's not what you do. That's not what you need to do. If you have Chrome, I actually think it's one of the better profiling tools for this. So we're going to go through how you do that. Awesome. So before we go into that, though, what I'm going to do is quickly cover how things are rendered on the page. That's going to make a whole lot more sense when I get into the profiling tool. So when we're going through our rendering cycle, what the browser does, right, the first thing it does is it goes and constructs your DOM tree, right? This is reading in all the HTML, seeing what's going on, basically presenting that on the page for you. Then what it does is this thing called layout, which actually happens recursively from the top left. This is quite expensive. You're going to see a lot of layout problems again as we're going. I'll put these slides online as well, just so you can read them through later. The thing with layout to keep in mind is it's highly interdependent, right? Layout components typically will rely on each other to understand the whole scope of the page, the whole shape of the page. So we want to both keep that cycle as quick as we can, but also we don't want it to keep firing later on as we're writing better and better animations. So some of the things that affect layout, if you're curious, these are our CSS properties that are basically layout-based. So you can see there are things like widths, heights, text aligns, overflows, white space, stuff like that. Things where you can see that this rule isn't contained just to the node that it's being described on. It's kind of going to affect everything around it and probably the whole page. And basically, when we change those properties, we hit a reflow, right? Who here knows what reflow is in general? Only a couple. So reflow is basically going to be your enemy when you're building hybrid in general. If you're going through your app and you're seeing all these clunks, your app's basically reflowing, having to go through that layout process over and over and over again. So as an example, right, if you go and just change the width of a single node, you probably just caused a reflow on the entire page, right? Because it can't tell up front whether or not changing the width of just that node is going to affect everything around it that has different overflow properties, stuff like that. So what actually causes a reflow? One is changing those CSS properties that I just showed you. Some other stuff that seems pretty obvious, but not always. Anytime you actually resize the browser window, which you can't do in hybrid, but that actually causes a reflow as well. Where this will bite you is as you're doing your profiling, I've watched people try and get the animations together as they're running, then wonder why they have this huge performance dip out of nowhere. And it's because everything's going through and being recomputed. Any of your computed styles with JavaScript, and also just removing elements from the DOM. So later in the talk, I'm going to show you how you can actually take an element off the page without actually deleting the DOM node. So if you go through and delete the DOM node, you've again caused a reflow. This is not what we want to be doing. Then we hit our paint cycle. So paint styles are basically things like borders, background images, color, outline style, stuff like that. Easiest way to think about these is they typically won't affect the nodes around them as much. If you're interested as well, opacity is actually a special case in Paint. If you push the element to its own layer, which is again something you're going to see, it's not actually going to need to go through and recompute anything. We can actually just go through and it will recompute basically the alpha mask for you. The last part here is composite and layering. So what a lot of people don't seem to also follow is that you can actually split different nodes to different layers, in Chrome and Safari and all of your browsers. But the default is everything is flat and it's only in one layer at all times. So I'm telling you all of this now, so as we go through examples and look at a flat page and start trying to promote layers to make them work a bit better, we kind of understand why we're doing that. So with layers, the default is a single layer. A composed layer, which just means a layer that's basically being separated from everything else, is far more efficient to animate, right? Because we kind of know up front that it's not really going to affect as much around it. But sometimes when you tell people this, the next thing they do is go and push absolutely everything to its own layer, which you've just made the problem so much worse. So as a general rule, don't promote anything to a layer until you're starting to think about and you're seeing some type of dip. A good example of where I'd use a layer is when I'm building burger menus on Hybrid, for example. Typically like that to be in its own layer just so I can trust that I'm getting the best performance there. That's not something I really want to see dipping ever. Layers are also expensive, right? So basically the size of those layers is bigger than you might think. It's the width times height times 3, right, for our RGB values, basically. So every time you're pushing a new layer, you're actually increasing the memory footprint of the app versus having kind of left it as it was. It's not always noticeable if you're just doing it for 1 or 2. But again, if you're getting to a point that you have 15 or 20 promoted, you're going to see that get bigger. So how do we promote a layer? If you've never seen it, this is where the will change property in CSS starts to come into play. So what you can do is you can say will change auto. And that's, again, if you don't really know what you're doing yet, you don't really know what you're going to animate, will change auto will promote it to its own layer. But if you can, what you want to do is say will change, say, transform. And that's giving everybody a heads up that we're actually going to be running a transform on this layer. And again, you're just going to benefit from a whole bunch of optimizations that honestly, even I've not really read into as deeply as I should, because it just works for you. And you should be happy with that. I work in Ember. This is how I think about the world. So just to show you an example here before we get into some real animations. This was a very early example of the animation example I was writing. I came up with something way better than this. This is actually what my UI designs look like, which is why I write code. So you can see I have like a purple bar, 2 other bars, a gray background, and a bunch of green boxes. And that's all being pushed to a single document layer. So then what I did to those green boxes is I went through and just said, will change transform. I added that to that CSS property. We go through and look at that again, and you can see that we've actually gone through and everything's being pushed to its own layer. If you can't see what I'm doing here, I've actually just popped open the Chrome developer tool, and there's actually just a tab called layers. It's sometimes hidden in that secret menu you need to open. Once you do that, you can get a bit of an idea of what's going on. And you'll notice there's some information down the bottom here in terms of just, what are our size, what's going on there, what's the memory estimate. So you don't need to go and do that math yourself. Another thing to be careful of before we get into the examples, I've actually put this in the examples to slow them down, is layout thrashing. So especially as you're working in Cordova, for example, even if you're using a framework, I see people are using jQuery selectors or something like that a lot to go and pull a node from the page. So what you can see here is I have a really naive example where basically I'm adding 20 to left and I'm moving the boxes left by basically 20 pixels every 500 milliseconds. The actual problem you can see here is this box CSS, so I'm pulling those selectors every single 500 milliseconds. So that's what we call layout thrashing. You don't need to go that way. You can just generally pre-declare that box as variable and off we go. So again, little things to be careful of, but it's amazing, right? And I catch myself doing it sometimes as well. I'm just writing code as quickly as I can. And I look and realize that, oh crap, I'm running a jQuery selector every single time here and I don't need to be. Something to be conscious of. So last thing we're going to do before we do some real animations is look at the profiler tool so we know exactly what we're looking for here. So if you've never seen this before, again, just pop open your Chrome console. I typically do all of my profiling for these in Chrome just because I find it gives me better information, it's easier to use. Hardest part about using the profiler for a talk is running the profiler and QuickTime on this Mac does not go very well. So Fan does not like me. So what you do is you open up this performance, and then you'll notice there's a record button up the top. And this basically lets us start snapshotting a moment in time on the page, right? So you might want to do it from boot. You might want to wait till everything's loaded. You have the power to choose that. And what it will do is, once we've recorded, it's going to show us something like this. So at the top here, these green bars you can see where you have 1,000 milliseconds, 2,000. That's basically the timeline of the page. How long did our recording go for? And that huge wavy thing you can see there is my frame rates. That's a terrible animation, right? Typically, as we're profiling, what we want to see is that line to be as straight as possible. We want it to be 60, but we prefer it to be straight than 60 sometimes, 60 no times. What's going on with these little screenshots down the bottom is it will actually also take a screenshot of the state of the page for you at all times. Again, you can do this with your hybrid apps as well because they're basically just web apps anyway. So I profile them in this context because I find it's a bit easier. Pro tip with the screenshots though, I do have a lot of cases where it does drop my frame rate for reasons unknown. I mean, it's taking a screenshot all the time. So I'll leave it on when I start, and if I'm seeing a dip that I can't explain, I'll just run the profiler again without screenshots enabled to kind of see what's going on. Otherwise, we don't really need to go into the rest of this yet. You'll see in examples. Otherwise, just keep in mind here, right? You get this wonderful piece of information in terms of how much time was spent on scripting on your page, how much time was spent on rendering, which we spoke about earlier, and how much time was spent on painting. And these are the three variables we care about most as we're getting into writing an animation. Look at that. I went through and highlighted all of these, but we don't care. So this is the scene we're going to animate. If you don't recognize who this is, I'm pretty disappointed. It's from the greatest show on television, which is Survivor. Can't play it, I live in Canada. But what we're going to do is basically go through, I had this whole big animation plan that I didn't finish, so the fact that Jeb Prost there has nothing to do with the animation, I just never took it out. He can hang out though. What we're going to do is go through and animate some green bars across this page. And the reason I'm doing green bars is it's a really simple example to understand versus coming in and having built this whole mobile app and trying to explain that the network request, and then it's not really an isolated example we're looking at together. So our goal is to continuously animate bars across this page without really having any dip. So let's go and do the first animation, which is straight up the worst case. So what I've done here, right, so we've got some pre-declared variables at the start. This clear my Mac or save my Mac you'll see why I need this later, because this just straight up clogs up my machine just running this animation for more than a minute or so. But what I'm doing is when the document is ready, I'm going through and running this function called animate absolute, which you'll see next. And what we're doing is every 250 milliseconds, we're basically going through and adding to the container div another green bar that we're going to animate across the page. You can probably already see some layout thrashing here and why it's not fantastic. But if you want to see something even worse, let's look at animate absolute. So what I'm doing is every 10 milliseconds, like I said, the most naive example, I'm going through and getting left boxes. Then I'm going through each of those boxes and basically changing the absolute position of them every 10 milliseconds to make them go across the page. If you're wondering why this is bad, we're going to talk about why this is bad. But first, let's have a look at how it actually works. So what we're going to do is just animate some bars across Jeff here. And it starts out OK, but we're already starting to dip, right? We're clunking all over the place. And you saw nowhere in the code why this should be happening right here, right? We're actually starting to clunk up all over the place. And we're still running. By the way, I have some sweet fires in the background if you haven't noticed. But we basically ground to a halt at the end of this animation. And this was a point where I actually just had to stop running it and turn off QuickTime because my Mac was ready to die. So let's go and look at that in the profiling tool. So the first thing we see, right, is our frame rate up the top here. Lots of dips, but it's basically declining the whole time, right? So as time goes on, we're not remaining constant. We're just straight up losing frame rate for some unknown reason right now. What I'm doing here, if you haven't noticed, is you can actually go through and highlight the frames below, and it will tell you what the frame rate was. So if you're looking for a straight line, but then two, you can kind of go and highlight your dips and see what your frame drop was. I'll play that again just so you know what you're looking for here. Right, so that line is just dropping over time. And we want a bit more information as to what our rate actually was. So at the start, it's not bad, right? 50, 60, not terrible. But then, oh shit, this is not good anymore. So let's go and have a look into why that's happening. So problems, FPS dip, we just observed. every single animation is triggering a reflow, which is why we were talking about that before. It's triggering a reflow because I'm both just adding new stuff to the DOM because I felt like it. I'm not deleting old things from the DOM, and I'm changing absolute CSS properties, which is one of those ones that will trigger a reflow. We're not taking advantage of any of those hardware accelerated properties, which I said will run more performant. We're redrawing at a fixed but not fixed rate, which I'll talk about next. And actually, the worst offense here is that this is going to keep running in an unfocused tab. So as much as that was grinding my machine to a halt, it doesn't matter. You can like open a new tab, go do something else, and it's just going to keep powering in the background. So it's like a really nasty thing to do to your users. In a Cordova context, this is just straight up going to melt the app, right? They're going to have to force quit and open the app again. There's basically no recovery once you're in this scenario, so just don't get there. So when I said we're redrawing at a fixed but not fixed rate, a couple of things about JavaScript that sometimes surprise people. One is interval timing is actually not guaranteed, right? You might have a 10 millisecond interval, could fire at 9, could fire 11. It's kind of like a best effort sort of guarantee, but not really. So that's where you started to see those bars were clumping together. As more work was happening on the page and the thread started to get clogged up, that just meant those intervals were not actually firing at a consistent 10 seconds anymore. That was responsible for the spacing because I put no further logic in there. Thus, we started to really clump up. Other thing about set interval, though, all these timeouts, is that when a tab is inactive, it's still going to fire. It's just going to fire roughly every 1 second, no matter what interval you put in. So now we have this second set of fun, whereby we unfocused the tab, our computer was melting, we went back to the tab, and now, oh God, what's happened? Like, just shit's all over the place. So before we go in and try and improve that, let's just quickly talk about CSS3 animations, which are our keyframe properties. So this is actually how I did the flames. I have a site point link down there because I just stole their flames because I didn't want to write flames myself. But you can see here, that's the code for the flame. And then what they've done here, 0, 100, 25, 50, 75, I didn't question why they wanted to order that way. It's OK. But basically what we're doing is you see here animation flicker, 1.3 seconds. Then we're basically defining the intervals and what we want to have happen there. So this is what a CSS animation looks like. You might be noticing some problems with this as well, though, right? That it's pretty hard to dynamically set a start and end point, right? All of this is defined upfront in CSS. And this is actually the problem with these animations, right? They're fantastic for buttons. They're fantastic for known elements and stuff like that. Where you can't use stuff like this is if you want to, say, have a bar that's being injected and it's going to be changing its position a lot. Your only option there is to go through and continuously push new CSS rules for each element you've added to the page. That's going to be an even gianter cluster than what we had before. So I wanted to quickly cover what those were. If you're curious, some of the properties you can put there, you can put an animation duration, you can put in delays, timing, then you can also set your easing, right? So these are really fantastic for really basic small elements. They're not going to work for our example, though, but they're worth talking about. You may have also noticed that they're pretty hard to write, right? Outside of those starting positions, that just felt, as we're looking at it, it's kind of hard to follow. Let's be serious, most devs are not very good at organizing CSS to begin with. So this ends up in some giant 200-line file, 400-line file. And unless you're using something like an Ember, we'll typically pair our component template and our CSS and stuff like that in the same folder, so it's easy to find. That's not the reality for most apps, though. So you're debugging a component, you're just wondering, like, where is the stuff that's making this move? And you end up trolling through the whole application. So this is where the JavaScript animation API comes in. So what you can do is actually run your CSS animations this way. So we'll call the box.animate, then I'm basically setting a duration and what I want to have happen for each of those durations. Pretty simple, right? We're running translates because we know they're hardware accelerated. They're not going to trigger a reflow. And we're slowly moving something across the page. So this solves that earlier problem about it being quite hard to set, say, a variable starting position, variable ending position. The reason we're not using that today, though, is it's not actually going to work on Safari. And if it's not going to work on Safari, it's not going to work on iOS Safari, and it's not going to work for any of our iOS users. So something we need to take into account. So how do we start solving this problem? We're going to start looking at some hardware accelerated properties. So what we're going to do here is, right, we're going to start the box with the left position, and then we're just going to basically translate X, right? So these are special CSS properties. They'll typically come from GPU if you're handling things right. and they're not going to trigger a reflow. This is going to be happening independent of the rest of the work that's going on your page. So what I did is I went through and replaced that animate absolute with a function called animate translate. So again, we have intervals. It's pretty similar. The only real difference here is this line, which you don't need to care about. This is just me pulling the last position off the page in a okay way. But here, we're going through and changing. So we're not going absolute left. We're just doing translate x. So again, what we know is that this is going to be a little bit more performant. Spoiler, it's not going to work as well as we hope, though. So let's go and have a look at what's going on here. Right, so we're starting off better. We're going kind of smoothly across the page. Some of the glitching you're seeing is, again, just Mac being unable to record. Right, still going, still going. Things are fine. We've definitely started grinding to a halt now, and we're starting to have the same problems we had before. So that was better for a time, but it's still not good enough. So if we go and have a look at this in the profiling tool, right, our theory was kind of right. That line is much straighter to start with, then after about 12, 13,000 milliseconds, it just starts to become not consistent again, which is our problem. If we go and look at the actual frame rates down here, right, 50, 60, 48, and as we get to the end, we've just ground to a straight up halt again. And that's how things are going to continue. So let's start thinking about what we can do to fix that. And there's a bit of a hint right down here. We spent a metric crap ton of time on scripting for, well, not reasons unknown, because I'm going to talk about why. But before we do that, if you didn't look at the scripting earlier, right, so the first example spent about 6,200 milliseconds in scripting. Just by changing the way that CSS worked, we dropped that a little bit. Most importantly, our rendering time has completely, we've basically halved that. But the time we've spent painting has gone up, and that's okay. Painting is typically going to happen a little bit faster. We've already cut a lot of time from the app, but even if you're trading things from, say, rendering to painting, don't be afraid of doing that. So let's look at what our problems were to start with. FPS dip, sort of solved, not really solved. Right? If we're doing something small across the page, we're probably good. We're not actually triggering a reflow for each animation anymore, so that's why you're starting to see especially that rendering cycle drop. We're taking advantage of those hardware accelerated properties now. Some other problems, though, is we're going to keep running an in-unfocused tab, and we're still redrawing at a fixed rate. So let's talk about some animation frames. Again, just out of curiosity, has anybody here used animation frames before? Awesome, only a couple. So animation frames have been around for a bit, but they don't seem to be in broad use all the time. All major browsers will support them. It's going to work on mobile iOS for you. It's going to work on your Android Cordova apps as well. And a couple of things about them. One is that they're actually only going to draw when the animation will be visible, so we don't have that unfocused tab problem anymore. User can go off, can come back, and the animation frames won't fire. They also won't run until the browser is ready. So if we have this problem with clogged up threads or other frames running, doesn't matter, we're not going to get this problem where we've backlogged our queue so much that this single-threaded environment is just melting right in front of us. And it also eliminates a lot of unnecessary draws and overloaded callbacks, right? So again, because we're using an actual API here, it's going through and doing some optimization on your behalf that we weren't receiving earlier. If you're curious, if you're targeting Opera Mini, you're basically fucked. Otherwise, you're fine. So, I mean, you are whether using animation frames or not, though. So let's have a look at what an animation frame looks like. So again, I've basically gone and taken that index page again. Progress array, you'll see in code why I'm doing that. But this window.requestAnimationFrame is actually how we go and basically kick off that animation frame process. Then what I'm doing is, there's a set interval here. We're still going through and adding a new box in. So we're still going to reflow a little bit. But every 250 milliseconds, I'm basically going through and pushing these animation frames to an array. And then our animate frame function here. So what we're doing, first you'll notice that we can actually keep calling this recursively, right? So we can keep calling animation frames as we go. And once one animation is completed, just basically queue the next one, queue the next one, queue the next one until we're done. The other thing that might be different here for you is we actually have this thing called progress, right? So we're going through and looking at the current time, minus the time that this bar entered the window, basically. The reason we're doing that is because what we want to do is also get rid of the fact that when our thread starts to clog up, we don't want everything to be all over the place. And the only way to do that is to actually start measuring time yourself, basically. So what you can do to keep things smooth is go and look at, okay, what time did this start? What is the current time? How far did I expect it to move? And start animating that way. And if you calculate those offsets, you're not going to have the same problems where, say, all of those bars were clumping up. So if we want to look at an example here, right, so it looks a bit different at the start just because I was too lazy to go and get all the math perfect for you. That's just basically going to keep running and running and running, and it's not going to matter. Right, and even if our browser starts to hit a slowdown for whatever reason, right, our animation might get a bit slower, which we'll talk about ways to get around, but we're not having the spacing issues we were having before. So if we go and look at this in the profiler, right, we're seeing a couple of things immediately. We had a couple of dips there. Whoops. But otherwise, that line's pretty straight. I'm going to show you a natural video of this profiler a bit later. Our frame rate is consistent, and if we go and look at our timing here, so scripting time is almost halved now, right? Because we're not doing all of this extra work in JavaScript that was completely unnecessary and backlogging everything. We've actually increased the rendering time a little bit in this example, and painting as well. That's okay, right? We've cut so much time out of scripting, it's okay to reallocate resources a little bit. So if we go and look at what some of our problems were, right, that FPS dip is effectively gone. We're not reflowing our animations anymore. We're taking advantage of some better properties. We're not going to keep running an unfocused tab, and we're going to keep redrawing at a fixed rate here. So again, where this will start to affect you is like animation frames is something I use a lot when I'm having to implement infinite scroll, for example, right, where I want everything to be perfectly smooth as somebody's, say, flowing up and down the page. This could still be a better example, right? So there's an immediate reaction because if you looked at the code, I wasn't actually deleting any of those bars. So what's going on is as they're off the window, they're still there, chilling out, moving further and further and further to the right, even though they're not visible, nothing's going on anymore. So usually the first reaction to something like this is to go through and basically delete those nodes from the page. Don't do that, it's going to make things worse. So what we're going to do here, if this is too hard to see, I can pull this up in Vim as well. By the way, I use Vim. And yeah. So what we're going to do is if the pixels is greater than the width of our screen, what we're going to do is basically just go and start recycling those divs and moving them straight back to the starting position of -20 to the left. So instead of adding new ones all the time, we're going to go and pre-declare a page full of bars and just basically have them run almost like a carousel. So let's go and look at that. I actually have an example here. Right, so we're running much smoother now completely, right? You're not seeing the same jitters you were seeing. That's in part because we're actually not reflowing at all now. I'm not adding anything new to the page at any moment. And as something hits the outer reach of the page, it's basically just getting moved straight back to the left. I had that running in the background the whole time, too. So if you wanted to see what that looks like in the profiler, right, so now all of a sudden we've gone through, you're not actually seeing the couple of dips that we had left before. So we can explain away those last couple of frame rate dips we saw on the first animation frame example were because we were still injecting new things to the page, and the later examples were because the DOM got so clogged up after a moment, because I probably had thousands of those things on the page, that, right, just things are going to melt when you do that. This environment is not built to handle something like that. So if we go and look at our profiling again, so that scripting time that I think was 12,000 milliseconds or something like that at the start, we've actually cut down to roughly 1,000 milliseconds of time now. So huge, huge saving. In terms of rendering, that's being completely cut out as well. So all of that extra rendering time was just because we were injecting new stuff as we were going. We've actually managed to cut out paint cycle as well. This is just a function of less things being on the page now that we need to work with. So while we have some time still, I'm going to cover some other things we could have used here that are maybe not as well supported. The first one is the intersection observer API. So this is really fantastic if you just want to see, did a node touch another node, basically. The reason I don't use it, and I didn't use it in these examples, is again, iOS, Safari, no support right now. Or no support when I took this screenshot a week ago. I hope it hasn't changed. So this is how they describe it. It lets you, basically asynchronously observe changes in the intersection, yada, yada. Let's just look at a simpler example. So what we do is we go and declare a new intersection observer. You can say what callback you want to have fire. The callback will happen basically when that intersection happens. The threshold, which we can define, is how much overlap do we want to be seeing before that's going to fire. So say we have 2 boxes or 2 triangles or something like that. Do we want them to be touching by 10%, by 50%? What are we looking for? The root, right, is which node is basically our listener in this scenario. If you don't define it, it's actually just going to happen on your top level viewport, which is probably not what you intended. And you can also go through and define this property called root margin. If for whatever reason you don't want to use threshold or want to use both, right, you might actually want some safe edges, right, and to add 5 pixels or 10 pixels to those margins. So it's going to fire a little bit sooner than a complete touch. And basically what you do is then on your observer, you just call observe, pass in your div, and that callback function is going to fire when those 2 divs are touching. So I can't wait for this to be supported in iOS Safari, because it's going to make my life so much easier than the way we handle this now, which, to be honest, is just basically doing our own math to see if things seem like they're in the same spot or not. Last quick one here, because I have a couple of minutes left. If you've never seen them, passive event listeners, we didn't really talk about in our example. Again, no Opera Mini support, no IE, like no old IE support, but that's probably fine, right? I don't think many people are using Cordova to build Windows phone apps, so we're safe there. But what it allows you to do is basically indicate that we're not going to call prevent default. So it's a really small time saving, but stuff like this really starts to add up. So say we're doing a touch move listener, right? This is something that I do all the time when I'm building hybrid. As your last parameter, just pass passive true. And we've now just basically given a heads up that we're not going to be calling this, and a couple of little time savings are going to happen on your behalf. So just to close up in terms of what we consider best practices right now for working on this, we're straight up avoiding the JS animation API. I'd love to use it, but I mean, the point of hybrid is to write one piece of code that's working everywhere, and it just seems kind of ridiculous to me to then go and special case my animations based on the platform. It's fun to play around with, but it's just not there for us right now. So for pages with smaller animations like a button bounce, those CSS and hardware animations are fine. I might even use those CSS3 keyframe animations. And sometimes, right, especially transitional stuff like a burger menu, I'll actually promote that to its own layer so I can kind of trust I'm getting the best of both worlds there. When I'm starting to hit a lot of animations, though, I'm animating complex thing, or it's kind of based on math context of the page, right? It's not defined up front. We go straight to using animation frames. We don't try and write an absolute animation or anything like that. We'll go straight to basically calculating our own time and working that way. And the actual benefit for us has been that we've been able to trust that consistently things will be in the right spot, which is really what we want, right? We've all used the apps where you're scrolling and suddenly it like judders up 10 pixels or it like shifts across 5 pixels in front of your face. That's not good. That's when people say, hey, this is a hybrid app. It's garbage. Why didn't you build native? And you're trying to explain to them that actually it didn't need to work this way at all. So that's the end of this talk. I don't know if I have time for questions. It was 10. Right on time. Thank you, everybody. I'm here for the next few hours if you have any questions.